Hello students, today I will be doing the exercise on Java inheritance. So you must have been taught inheritance in Java. So this will be the exercise, and as usual the exercise will involve some Java codes that will help you understand how to implement it in practice. So let's start. Just a little bit of a recap on your previous classes on inheritance. So let's look at this this diagram. Let's look at this diagram. Let's have a diagram on, say, the banking system. So if you have a bank as an institution, and of course you can represent it as a class in your Java code, then under the bank you have bank account as another class. And then you have other accounts. Under the bank account you have some types of accounts. For example, current account, savings account, children bank account. So something like that. And then under, say, current account, you can have options A and B, whatever they are. And you can have other options here too, but just for illustration. So if we are going to look at inheritance as it is, we will say that bank is what? Is the superclass of bank account. And bank account is the subclass of bank. And in Java, if you want to describe this, you will say bank account extends bank. And it will inherit, and bank account will inherit ever more properties here. That is the objects that are defined here, the methods, you will inherit them here. As well as you can say savings bank account extends what? Bank account. And current account extends this. And children's account also extends. So these three are on the same level, and all of them will inherit all the methods, the properties in bank account. The same thing, A will extend current bank account, and B will also extend, and both of them will inherit all the things that are here, as well as the things that are in bank account and, of course, in bank. So it is a way of generalizing concepts. So this we consider it as generalization and specialization, if you remember these two words. So the most general in this diagram is bank, because it has everything that all the other subclasses up to this level will have. They will inherit it. But this one is more special than bank account is more special than bank. And these three types of bank accounts are more special than this. Why? Because they have everything here and here, as well as the other things that these ones don't have. So the most specialized in this diagram are A and B. So now we understand the concept of class inheritance in Java and in any other programming languages, whether C++ or Python, they're similar. So let's now go ahead to look at some codes, Java codes. So using inheritance to make variations of a class. So you want to vary them. Let's go back to our diagram. You want this current account, savings account, and to be different from bank account, and this AB to be different, to have some special things. That is what we mean. So there will be a series of questions here. So the first 4 asks for subclasses for bank account to be written. So one advantage of this is that the subclass of bank account only needs to contain those aspects which it varies with bank account. So otherwise it inherits what is in bank account. So another advantage is that any code which takes argument of type bank account will also work by taking an argument that works with the subclass of a bank account. For example, the one you saw in a bank. So it's like dynamic binding and the variables and the rest of it. So let's go on to see some codes. So for example, we have a class called a class bank account. So public class bank account. So we have defined some private instance variables, private integer, ACC number, that is account number, private string, account name, and private double balance. So now you have a constructor. So remember, a constructor is like a method that has the same name as the class, but the default constructor is no arg constructor, that it doesn't have argument. So this is you override it with this one, so it has argument. So and then this one, these methods are defined under this class, and public int, you get account number, you get account name, and then you get the balance, and you add them up. So let's continue. You have another method, is a boolean, remove, and you have another and other accounts to deposit. As you know, in bank account, you deposit money, you remove money, that is, you withdraw money, and then you can manipulate the bank accounts. So you can define variables as public, private, and protected. So public means it's available to all the classes that inherit them, as well as to other methods that are in that class. So private means is private, as the name private, is available to that class alone. And protected, we will see that it is protected from manipulations and the rest of it. So note that in bank account, the variables account number, account name, and balance are declared as private, which means they cannot be accessed directly by code in a subclass of bank account. However, their values can be obtained by calling the public method get account number, get account name, and get balance. So you can obtain them because they are publicly. If a method was declared as private, it also could not be accessed directly in a subclass. For example, if the method remove, which is defined in the previous class, was declared as private and you wanted to overwrite it, you could not then call super.remove amount in the override code, in the overriding code. Calling super.remove amount is what you need to do if the code that overrides the method remove needs to make a call, because this means within that that method, that class, and then the code will be overridden, will override the ones that are in the superclass. The general idea of methods declared as private or protected is that they are there not for direct use by other code, but to help structure the internal code by breaking it into separate parts. So for example, here is how you will override remove in a way that creates a count of a number of codes. So you can do it this way: protected boolean remove, and then you can call it this way and you return it by using super.remove. So the methods add and remove in bank account are declared as protected to mean that they are not available to be called by any other code, but can be called by code in subclasses. By any code, but can be called by codes in the subclasses. If a method was declared as private, it also could not be accessed directly in a subclass. For example, if the method remove was declared as private and you wanted to override it, you could not then call as super.remove in the overriding code, as I said earlier. So calling super.remove is what you need to do that. So the variable remove count needs to be declared as additional instance variable. As I explained to you yesterday in another exercise, that instance variable are variables that are directly declared under the class and they have default values assigned to them. So let's look at, so these are the questions that you need to address in your exercises, having given you a brief example of what inheritance and some few codes. So now what you need to do is to do these questions and practice them to understand inheritance. So question 1, interest account. Write a class called interest account that has an additional double variable called interest. Remember, we have a balance, a variable called balance. So you should improve on it by putting another double as interest, and method called add interest. So when a method called add interest method is met, the amount balance times interest is added to balance, and a message interest added is printed. The variable interest has its value set by the constructor of interest account. Remember, I have explained what a constructor is. A constructor is like a method with the same name as the class. So in this question, this is one way to do it. For example, you can put interest account equal to new interest account, but you must have what? Declared interest account as a class, as defined. And then you can, you remember we already have the deposit method. So you can say acc.deposit 300 and what? The interest, and then you add the interest, and then you print this account. It will cost deposit 300 successfully, and then interest added. So account number, whatever you've added, and the balance, so to be printed. Please do this exercise. Another exercise, question 2, overdraw account. So overdraw means you've gone beyond what you've deposited. So it will be in the red or minus. So write a class called overdraw account that works as follows. Where in bank account a call remove amount will return false and make no change if amount is greater than balance. That is, you have withdrawn more than you have. For example, if you have maximum 1,000 RMB in your account, and then you are going to withdraw 2,000, it will give you false because you don't have that amount. You are overdrawing it. So with overdraw, it will still return true change balance, so long as balance does not exceed below a limit of the constructor. So you will have a limit that you can overdraw, that you can draw. So just look at that. For example, this is how you can define it. If you define this, this is how to create the instance, and then the deposit, and then the withdraw, and print whether it will cause any problem. And look at this. Please just look at this example and go ahead and do it. Another exercise, question 3, fee account. So you remember this is a type of account under bank account. So write a class called fee account that works as follows. Each call of withdraw has a fee which is taken from balance. So if you withdraw, you will be charged a fee. So the charge is made whether or not the call of withdraw can remove the amount given as its argument. The fee is set by the constructor. So you know what a constructor is. Put the fee in the argument or wherever, and then do it. This is, for example, this is how you will do it. Please just look at this code and read it and understand it, and look at what it will call, and it will be printed. So it will help you. The next exercise, question 4, fee account again. So you modify the version of the fee account that you've just done in the previous slide, called fee account 2, so that when a fee is paid, the fee amount is added to the balance of another account passed into it by the constructor. For example, look at this code, study it, and see how the fee is added onto it and printed. It will cause these actions to happen. Just study it. It is an exercise, so go ahead and do it. So let's look at model view controller, so what we call MVC. It is a design pattern, especially used in e-commerce, that divides programming into 3 parts. You have the model part, which usually you use the Java code, the normal Java code, and then the view, which is the output and input interface, which usually you can use JSP, okay, that is Java Server Pages, and the C, which is the controller, which connects the view and the model, which can be used by servlets, that is Java servlets. You have been taught servlets in your cloud computing and some Java programming tasks. The class bank account has code that represents an account for internal use with code that prints messages that human users can read. In general, it is best to follow model view controller idea that code interacting with human users should, as far as possible, be kept separate from code doing internal calculations. So consider the following classes to represent bank account but does not print itself. So the printing part will be the view. The model will be the calculation. The controller will be the one that links the calculation and the view to provide an interface and output. So public class, bank account, private, just you've seen this class. So instead of what? Printing, you don't see printing here, only perhaps the calculations and the rest of it. So, and then we have seen these codes. So just follow the codes and do it. So print account. So write a class called print account. Now this one will do the output for you. That works just like the first class bank account. So it should do this by putting the actual printing code in the overriding methods, and those methods will cause the internal calculation to be done by using the code they override by method called attach to super. So now you have a different class that does the printing, which is the view for you. So print table account. So you read this and continue. So write a subclass of basic account called printable account, which works like print account that we've seen in the previous class again, the previous slides. But instead of printing a string, it calls print.send string, where string refers to the string and printer refers to an object stored in the printable account object. Write a separate class for this object where when send string is called on it, it prints the string. So observable account. So we have accounts that will observe what the method that does the calculation, as well the method that prints to see if things are going okay. So write a modified version of the answer to question 6, that is previous slide, called observable account, where instead of printing printer.send, it makes a call observer.send this command string. Here, as well as printing the message referred to by the string. So the object referred to by observer should print the number and name of the account represented by the object that the call to send was in. So using the first argument to the method call, so that you will be able to do it. So you just call the ACC1.deposit and this, and it causes this to be printed. Please just read it and go ahead and do it. So remember, we have looked at some few design patterns and principles. So we have looked at the MVC, the model view controller, and there is also the observer design patterns that you will be seeing it. So if you write these codes and if you do this exercise, you should be able to understand inheritance very well, and of course the design principles, model view controller, as well as observer principles. Thank you. If you have any questions, just send it to us on QM Plus and we will try to answer it. Thank you and bye.